Okay, welcome back. Now we are going to talk about dilation. In the previous part, we talked about erosion. Dilation is basically dilating the image, where you can see here the intersection of A with B is equal to phi. So basically, dilation is adding or the set of all displacement z of the translated b and a are overlapped by at least one element. If we have an overlap of at least one element, then we are going to move the values. So as you can see here, dilation of this pixel, when we put the pixel over here and we find the pixels intersected here, then the image will be, this part will be included in the image. As you can see over here, this is the dilation of the images like we did in the previous erosion. Now the same applies over here. As you can see here, nothing is happened. Now still nothing has happened because this is our structural element. Now this pixel is part of the structural element, so pixel 1, 2, 3, 4, pixel 1, 2, 3, 4 now is part of our structural element of our image. Okay, pixel 4, pixel 5, pixel 6. Okay, then pixel 3. Then these are of course part of the pixels, which is here. Okay, then out. Now pixel number 2, then 3, 4, 5, 6. Okay, the rest are the same. Then pixel 1. So if we continue on this stage, as you can see here, step by step we dilate the pixels, we end up with this image where the green ones are the dilated pixels which will be included in our original image. So the blue is the original, the green ones are the processed pixels which will be included in our actual image. So dilation will increase the size of the object. Dilation can repair the breaks. Dilation can repair the intrusions. So you can see here that dilating this image, which is letters, so these letters will be improved, as you can see, and the writing will be somehow improved. Now duality is is basically one of the properties where we have erosion and dilation are duals of each other with respect to the set of complement and reflection. So here A A eroded by B complement is equal to A complement eroded by B reflection. Okay, the same applies over here. These are the proofs for these two properties. Now, why do we need these properties? Because we want to go into opening and closing of images. Opening generally smooths the contour of an object, breaks narrow elements, and eliminate prostrations of an image. Closings, on the other hand, smooths the sections of the contours, but it generates and fuses narrow breaks and long, thin gloughs. So eliminates small holes and fills gaps in the contouring. So we have closing and we have opening. So what are they? So basically, opening is of a set A by a structure B is denoted by this symbol and is denoted as the erosion, then dilation. So we erode A by B, then we dilate by B. Closing, on the other hand, is basically the this is the symbol for closing. We dilate A by B, then we close it by, then we erode it by B. Remember, okay? Remember. Okay, remember this is the symbol for dilation. Okay, and this is the symbol. Okay, just go back. This is the symbol for, where is it? Okay, sorry. This is the symbol for erosion. Okay, erosion looks like the negative. Erosion, it's making the object smaller, so think about it as negative. Where dilation is making the object larger, think about it as positive. Okay, now also opening and closing is doing the thing twice. So here in opening we dilate, sorry, we erode, we erode the object, then we dilate it, we make it smaller, then we enlarge it. And in closing, the last operation is closing. Okay, we dilate, then we erode. Now you can see here that this is an image. This is the image after opening, and this is the image, the same image after closing. Opening, as you can see here, it eliminated these parts. It eliminated this part. It eliminated this part. It eliminated this part. It eliminated these parts. While as closing, it eliminated the gaps in the image. Okay, all the gaps in the image were eliminated. These are considered as gaps, and they were eliminated. So you can see the difference of doing this for an image. So this is a figure A, the morphological operation of opening and closing. The structural element is a small circle, which is this one, shown in the figure. So these here we can see that this is the figure and this is the object. This is the origin using the disk. Okay, this is the opening of the image. This is the dilation of the object, and this is the closing of the image. So dilation, then closing, erosion, then opening. So this is how it is done, and you can see the operation as the object moves through the image, how it goes. So the duality A closed by B complement is equal to A complement opened by B negative, or B complement. So this is an example of the use of opening and closing, and you can see that this is a fingerprint with some noise. We do an erosion. We remove all small noises and see how thin the thumbnails become. Then we apply from here to here, we apply opening. Then from here to here we apply closing, and then apply opening once more. We get the result as you can see. So noisy image, then the structural element is this part over here, then the eroded image, which is image C, then image D, which is this one, is the dilated of the opening, then image F, which is the closing of the image, and at the end this is the image that we are going to find. So hit and miss transformation, as you can see, hit and miss transformation is basically if B is denoted by the set of composed by D and its background, the hit and miss the match or set of matches of B and A is denoted as A match B is A eroded by D intersection with A complement dilated with W minus D. So if you have these parts, which is C, D, and E, three objects, if you the union of them will be this. So this is our W. Now when you apply the hit and miss transformation, we get this full object where we have these values together. Now some morphological algorithms such as boundary extraction, which is used to extract the boundary of an object. So you can see that the boundary is, this is the boundary of, sorry, this is the boundary of this object, and which we got over here. So this is an example, hole filling, where we try to fill the holes. Okay, you can see that this is image, and when we fill the holes it becomes something like this, and this is an example for hole filling. So this is basically the part for morphological operations. Hope to see you all soon. Thank you for watching.